Problem 9 from Chapter 2. A 100-ton hydraulic punch press is used to punch holes in half-inch thick steel plate, as shown in Figure 2-9. If the average shear resistance of the steel plate is 40 ksi, determine the maximum diameter hole that can be punched. All right, got it? Got it. Let's go through what do we know. Engineering 305, problem 2-9. The givens, I've got a 1,000-ton press. That means the maximum force it's going to deliver is 2,000 pounds per ton. So times 1,000, so it's a 2 million pounds. We better check our digits when we do our conversion. I'm punching through half-inch steel plate. I'm going to punch a round hole. It gave me the failure criteria, and it gave me that the shear stress for the material is 40,000 psi or 40 ksi, kilopounds per square inch. Find the maximum diameter hole. So really the picture is again very important, but so is our observed relationship. That observed relationship is that the shear stress is equal to the shear force divided by the area. Now, what parts did they give us? What parts did they give us? Well, a 100-ton press, that tells us the force that is going to be pushed down. That is 1,000 tons. Sorry, I've got 1,000 tons, and I'm thinking it's 100 tons. I'm already making an error. It's a 100-ton press. It's a 100-ton press. 100 tons is the force that is going to be exerted. I'm going to convert that, and I'm going to go all the way back to elementary school techniques of saying 2,000 pounds is equal to 1 ton. And then that whole thing I'm going to divide by the area. The other thing I know, because I don't know the area, the other thing I know is the strength of the material, the shear strength of the material, which they gave us as 40 ksi. So what's my area? And for that, I think we need to look at our picture on the side. I'm going to blow this up. There you go. Now, that area is a circle. If I look at it from the top, it looks like this. But when I look at it from the side, and I can't, I've got to draw an ellipse here. It's got thickness. I don't know how to do that. That just didn't go right. That's going to go down to, that goes into there, and there's it. There's a thickness there. Okay, that's not it at all, is it? Yeah, that's not it at all. Never mind. Take a look at theirs. Take a look at theirs. You can see that thickness is a 1/2 inch. So this whole outside, we're not shearing this. We're shearing this circumference times that thickness all the way around. All right? That's why we take CAD classes, because it makes for better graphical communication. So that area, this circumference is equal to, do we want to do this in terms of area or diameter? It's asked for our diameter, so that circumference is pi d. And so then this area that we're talking about, this area is equal to the thickness times the circumference is equal to 1/2 pi d. If I shrink this back up, oh, that's not a shrinking move. Shrink that back up. I'm going to rewrite this equals 100 times 2,000 is 200,000 pounds divided by an area, which is, I'll just write it out as 1/2 pi times the diameter. Now the 1/2 has dimensions of inches and the diameter has dimensions of inches. So that's going to have units of inches squared if I just punch that number in there. And that's equal to 40,000 pounds per inches squared. And so now my units cancel out. Even though it doesn't necessarily look like it, I've got that pounds cancels with that pounds, so those go away. And my inches squared cross out with that. So if I punch that in inches, I'm all set. So now we rearrange. Now we'll rearrange, and I'm going to swing my D to the other side, D, and that means I've got equals 2, I'm putting the half on top, times 200,000 over pi times 40,000 equals, I can cross out 4 zeros on either side, and I've got 20 divided by, or I've got 40 divided by 4. I've got 10 divided by pi. That's something I can, see, I don't even pull out my calculator. Try not to pull out my calculator. And the mechanicals, you guys will get this from me in the spring, but this is going to be close to 3 inches. I know that's not good enough. That's not good enough for what we do. I got to get my calculator back out. I will make it a point to get a better calculator for you. So 10, enter, 3.14 divided by, and I got 3.18. It's approximately 3. It's equal to 3.18 inches. All right. There you go. There's problem 9.